Many states, including California and New York, require dangerous, expensive, and time-consuming hands-on labs in all of their high schools. I'm Harry Keller. I'm a scientist. I'm about to show you online, hands-on labs. You're looking at screenshots of actual data collection from the patented Smart Science Lab system. The first thing you'll notice is that these are real images of real science experiments, not drawings. Each Smart Science Lab begins with many video recordings of experiments, each one with different values of some experimental variable. The first screenshot shows data collection from a plant transpiration experiment. The horizontal red marks to the right of the vertical capillary tube show where a student has clicked with a mouse. These data do not exist before the student clicks. Sloppy students will obtain sloppy data. Careful students will obtain better data, just as in traditional lab. The second screenshot shows data from an aluminum object sliding down a wooden ramp. Each data point results from student interaction with frames from the experiment video. This system does not collect data automatically. Students really do own their own data, just as in traditional labs. Simulations do not allow students to collect data point by point. There would be no point. The third screenshot shows data being taken of tides, something you cannot do in school laboratories. Compare this data with remote robotic labs. Consider how you might possibly do any of the experiments you've seen so far with remote robotics. Not too easy, is it? Remote robotic labs such as MIT's iLabs provide data automatically, neatly packaged and ready to use. This approach is more like hands-off. The data are real, but the data collection is not hands-on. The fourth screenshot shows data collection from a photosynthesis experiment testing blue light on plant leaf discs. Here students must make a judgment regarding when to mark a disc as floating. Different students may well make different choices, just as in traditional labs. As each data point is collected, it is put into a data table, the black column near the middle of the screen, and plotted on a graph. Some labs allow for an optional curve fit. Teachers may turn off this fit for more advanced classes. The next screenshot illustrates how students can take qualitative or semi-quantitative data using a selection bar, seen to the left for this flame test lab. A data table would add nothing to this lab and has been omitted. The upper right corner of the experiment image contains a spectrograph of the flame, the cation is potassium. Students must also make judgments here with respect to matching the flame color to the colors in the bar, and later will decide on the identities of the unknown. Another and very different mode of data collection involves matching colors to obtain quantitative data. Here students match the color of an incandescent light bulb to a color bar. This bar has been calibrated to allow light intensity in lumens to be captured. Student care and judgment again factor into the values of data and their quality, just as in traditional labs. This screenshot shows an enzyme experiment. Different concentrations of catalase and hydrogen peroxide act to form oxygen, the gas whose volume is being measured. With online, hands-on labs, before a student starts a lab, there are no data. Not inside the computer, not on the server, not anywhere. The data come from the student's work, interactively taking individual data from the real world, not computer simulations. Students must exercise their own care and judgment to take these data. Now that's hands-on. Here's a friction experiment. Different masses and surfaces are dragged by a weight hanging down over a pulley. Students track the motion of the block. You can run real experiments, perform authentic data collection, and so satisfy reasonable hands-on requirements online. These data have the usual random and systematic errors you'll have running experiments live and local. They haven't been predetermined or made up. They only exist when a student takes them. They're a direct result of that student's efforts. Students can even skip some data points. These labs are every bit as good as the best traditional labs and are better than most. They cost less, use less time, take less space, and are completely safe. These patented Smart Science online hands-on labs are unique in the world. All students should be using them. Go to smartscience.net to find out more. A quick walkthrough of an entire sample lab will be found there.